Okay, so the first step in any of these is to understand the equation, right? That's what we tried to get to. So clearly this is in the wrong order, and clearly it's a parabola. So if you look at that, the correct order of this is up front, and this is in the other side. If that's a parabola, the maximum or the starting height when this is 0, at time 0, is 3,500. Now it would also be possible to come up where this height is, because that is squared. So the first step is, and I know D is down here, but the first step is, let's get rid of this minus 4.9. Doesn't matter what happened. I'll show you why. So when I take out the minus 4.9, I must divide both sides. Oh, it turns out this is huge. Yeah, I'm going to have to shrink. Yeah, I'm going to have to shrink this image. This image is huge. Like that. And I'm probably going to have to shrink it again. Like that. And there we go. So now I'm left with this, and I want to factor out minus 4.9, and it'll be very clear after this. And I'm left with t squared, and that is, we just take our calculator, and we take 3,500 and divide it by negative 4.9 to factor it out. It's going to become clear very soon. Okay, and we get this. And let's just call it minus 7.78, 714.9. Well, when does someone hit the ground? If this is someone jumping from a parachute, and clearly at time 0 the plane is at 3,500, my guess is because people, when they jump out of planes, maybe they get a little bump, but then they go straight down. So my guess is when this is going to show us he jumps a little bit up and then heads straight down. Well, what is the ground? So if this is height based on time, y-axis is here, and the ground is at 0, right? So at 0 he hits the ground, which means if we set this equation to 0 and solve this part, we'll see one area over here where he hits the ground and the other area over there where he hits the ground. Now, obviously, negative time's not going to matter. So let us, and I'm just going to get rid of this, let us look at that, at what's going on, and it most likely is something like this. Like this, and maybe he goes up a little bit, maybe. Now we set that to 0, and obviously it's only the bracket, and we set that to t when t squared is equal to 714.929, and we square root both sides. Now when you square root both sides, you have to add a plus and a minus. And when we square root that 714.29, we get, you could have just left in your calculator, 26.27, which means this is that. So that means that when he hits the ground, it's both at negative 26.9267 seconds here and here, which also tells me that this is not the correct drawing, that this would be the correct drawing, that on the y-axis it's equidistance. Why? Because the time is on either side, positive, negative of it. So that means it looks like this. Now the question, obviously, what are the reasonable expectations on the domain and the range? Well, obviously you can't go below the ground. So that means the range goes from 0 to the maximum height of the plane, and we've just proven that that's the maximum height. How do I know it's on maximum height? Because the axis of symmetry will be in between any 2 points on the graph that's at the same y level. This is at negative 26.72, and this is at positive 26.72. If I add them together and divide by 2, I will find the axis of symmetry. Obviously, when I add them together, I get 0 divided by 2, 0, which means at time 0, that's the maximum height, and we already know at time 0, that's the height, which means that's the reasonable limitation on the range. What's the reasonable limitation on the domain? Well, when he jumps out of the plane at time 0 to when he lands, 26. So the reasonable restrictions are on the domain. Let's see if I can get it. There we go. Domain, it's going to be x 0 smaller or equal to x smaller or equal to 26.72 minutes. Is it minutes? I don't know if it's minutes. I forgot to read it. It's minutes. Let's say it's really going to be seconds because he's in a parachute. could be minutes. It's probably seconds. And then the other restriction is the range, which is 0 is smaller or equal to y is smaller or equal to 3,500. And that's because this is a real life situation where this parabola has restrictions. What type of function is it? It's a downward facing parabola. Without calculating finite differences, determine which finite differences are constant. So for that, we know that it's going to be for a parabola, it's 2 times 1, and then it'll be 2 times its leading coefficient. So 2 times minus 4.9, whatever, 9.8, which makes sense because 9.8 is the gravity, acceleration due to gravity. Explain how you found your answers. Yeah, okay. Describe the end behavior of the function assuming there are no restrictions in the domain. Well, the end behavior is as x approaches positive infinity, if there's no restrictions, he clearly is y is approaching negative infinity. And D, graph the function state any reality. What do the t-intercepts of the graph represent in this situation? One represents in negative time, which can't exist, and the other represents when he lands on the ground. And if I go back to see if it's minutes or seconds, the ground height, and it's seconds. There you go. Not as hard as you would think.